Good afternoon. My name is Andy Keller. I am president of Keller Blissner Engineering. We are an irrigation and water resources consulting firm based out of Logan, Utah. We are known for our expertise in consumptive use analysis, water budgets, and water rights, which is part of the reason we have been hired by WaterPACK. We have been providing technical services to WaterPACK for over 20 years, starting with our work on the Rattlesnake Creek Basin and Quivira National Wildlife Refuge in 1997. From 2003 to 2006, we worked on the Middle Arc Subbasin water budget and modeling. We began working on evaluating the proposed Hayes water transfer in 2016. On a personal note, I began my professional career in 1975 as an irrigation manager, scheduling irrigation on several large farms between Greensburg and Pratt. As a result, I have some direct familiarity with the irrigation conditions in the area. I am sorry that I cannot be there today to give this presentation in person, but I do appreciate this opportunity to present on behalf of WaterPACK via video. Groundwater levels in the vicinity of the R9 ranch are declining, and this is happening despite a reduction in pumping on the ranch as circles are dried up in anticipation of the pending transfer. Spatial analysis and water budgets show historical groundwater storage declines as well, so the situation is clearly not sustainable and is a cause of concern, and any increase in water consumption will result in further stress. Let's take a look at groundwater level trends. This is work done by WaterPACK. They took water levels measured by KGS, DWR, and GMD5 for 10 wells in the vicinity of the R9 ranch. WaterPACK then plotted the water levels for each well for each year from 1995 to 2016. Each well is indicated by a unique color, according to the key at the bottom of the figure. The dashed lines represent the trend in the water levels. And as you can see, for each well, the trend is downward over the period from 1995 to 2016. This high period of water levels occurs in the late 1990s and is due to rainfall that was higher than normal during that time. The water levels for the 4 wells shown in this figure are deeper than that in the previous figure, but show the same general trend of decline from 1995 to 2016. This decline has occurred over the same period of time that pumping at the R9 ranch has also declined. This figure shows the annual pumping at the R9 ranch from 1995 to 2014, and it too shows a downward decline. So even though pumping at the ranch has been declining over time, wells in the vicinity have also been declining in their water levels. We also performed a spatial analysis of water levels. To do the spatial analysis, we took water levels from 521 wells as reported by KGS in the vicinity of the Middle Arkansas River Subbasin, which incorporates the R9 ranch. This yellow line here is the boundary of the Middle Arc subbasin. And here you have the R9 Ranch shown in orange. And all these blue dots represent the 521 wells that we used for the spatial analysis. We then used a statistical spatial analysis tool called Nearest Neighbor to map the water levels from all the wells in the vicinity of the Middle Arc subbasin. We then clipped that result to the boundary of the R9 Ranch, as you see here. So we can look at what has happened to the water levels. In other words, the change in water levels from 2001 to 2016 for the ranch. The average change in water levels for the ranch is almost 8 feet over that 15-year period of time, with less change near the river and increasing change, in other words, increasing decline in water levels as you get away from the river. This average decline is about a half foot per year for that 15-year period for the R9 Ranch. And it's nearly double the decline we found for the entire Middle Arc over the same period of time. But even more alarming is that what's happened on the R9 Ranch from 2001 to 2016 is almost 6 times the average decline for the subbasin in the period from 1988 to 2001. So the situation is getting worse with time, and it's not likely to get better given the high rates of water use in GMD3 to the immediate west. So we are concerned about the long-term sustainability of pumping in the vicinity of the R9 Ranch, even though on the ranch, pumping has been in reduction in anticipation of the pending water transfer. To avoid a worsening of the situation of the groundwater in the vicinity of the R9 Ranch, it is important that any water transfers from the ranch do not exceed the consumptive use that has occurred on the ranch. Thus, we performed a consumptive use analysis for the R9 Ranch. According to Kansas administration regulations, the criteria for change in use is that the net consumptive use must not be greater than the original irrigation net consumptive use. And if the estimate of the original irrigation net consumptive use appears to be unrealistic, which in this particular case we believe it is, then a site-specific net consumptive use analysis should be performed. Accordingly, we performed a site-specific net consumptive use analysis for the R9 Ranch using a process that's called metric to map evapotranspiration using 1984 through 1985 satellite imagery. That was the period of perfection of the groundwater use on the ranch, and then also extended that for a 30-year period using climate data recorded at Kinsley, Kansas. This slide cites the specific Kansas law governing change of use from irrigation to any other type of beneficial use. KAR 559A says that the maximum annual quantity of water shall be the net irrigation requirement, referred to as NIR, for the 50% chance rainfall for the county of origin,
in this case Edwards County, as set forth in KAR 5512, multiplied by the maximum acreage legally irrigated under the authority of the water right in any one calendar year during the perfection period. Turning to KAR 5512, we find the NIR for Edwards County for 50% chance rainfall is 13 inches or 1.08 feet. It is important to note that KAR 5512 gives only one value for change of use NIR at 50% chance rainfall, and that value is 13 inches for Edwards County. It does not give a number for corn and a number for alfalfa as requested by Hayes and initially found by the chief engineer. Furthermore, 559A says that the maximum change of use water volume is the NIR multiplied by the maximum area irrigated in any one calendar year during the perfection period. We do not believe there was ever a year when all circle acreages on the R9 ranch were irrigated. Finally, Clause C of KAR 559 says that if the quantity by Clause A appears unrealistic or could impair other water rights, the chief engineer shall make a site-specific net consumptive use analysis. We believe that due to conditions on the R9 ranch, Clause A of KAR 559, even if applied correctly, would result in allowing unrealistic quantities of water to be transferred. Therefore, we have undertaken a site-specific net consumptive use analysis of irrigation on the R9 ranch. So what are the conditions on the R9 ranch that require site-specific analysis? First, the sporadic farming history of the ranch suggests that it is unlikely there was ever a single calendar year in which every water right acre was irrigated. Fortunately, we have fortnightly Landsat satellite data going back to 1983 by which this can be verified. Second, the very low water holding capacity of the R9 ranch soils, which are some of the finest blow sands in the county, make applying water fast enough to keep up with the evaporative demand impractical, if not impossible. I want to pause here to make an important distinction between irrigation on the R9 ranch and water transfer out of the basin to the city of Hayes, Kansas. Any water pumped for irrigation on the ranch that is more than what is consumed returns to the groundwater and can be reused. However, in the case of water transfer out of the basin, for example to the city of Hayes, there is no return flow to the groundwater system below the ranch, and 100% of the pumped water will be effectively consumed. Therefore, it is imperative to correctly determine the net consumptive use of the irrigation water right to ensure that there is no effective increase in water consumption because of transfer out of the basin. So in an irrigation context, what is net consumptive use and how is it calculated? And how is it affected by a change in use? Consumptive use by an irrigated crop is the water that is lost to the atmosphere through evaporation from wet soil and other surfaces, plus transpiration of water by the crop plants. Collectively, evaporation and transpiration are called evapotranspiration, ET for short. ET is dependent on the atmospheric energy demand and water availability. On hot, windy days with lots of sunshine, there is lots of evaporative energy, and ET will be high if water is available to evaporate and transpire. If water is not available or limited, ET will be low despite the high evaporative demand, and crops will suffer water stress. We irrigate to meet the crop ET demand and minimize crop water stress. Crop consumptive use is equivalent to crop ET. Some portion of the consumptive use water comes from precipitation, and the balance comes from irrigation. The portion of the irrigated crop ET that comes from precipitation is called effective precipitation. By subtracting the effective precipitation from the crop ET, we arrive at the amount of consumptively used irrigation water. This is where the term irrigation net consumptive use comes from. It is the irrigated crop consumptive use net of the effective precipitation. In the case of a change of use of an irrigation water right, it is critical that the resulting new net consumptive use is not greater than the original irrigation net consumptive use. This is a matter of fact and law. For this reason, I have bolded the word actual on this slide. By actual, I mean the ET which actually occurred as distinct from the potential ET that could have occurred under ideal conditions. Given the low water holding capacity of the sandy soils I mentioned on the previous slide, it is difficult, if not impossible, to avoid crop water stress and consequential actual crop ET significantly less than what would have occurred under more favorable irrigation conditions. The second important point on this slide is that the portion of precipitation that goes towards crop ET under irrigated conditions is less than the portion of precipitation that is consumed under non-irrigated grassland conditions. This may at first seem counterintuitive, and it is a point often missed. But when one thinks about it, one realizes that under non-irrigated conditions, the only water available for ET is that which comes from precipitation, and ecosystems evolve to maximize use of the available water. Thus, to ensure that the net consumptive use does not increase with the proposed water transfer to haze, the calculation of the maximum transferable water amount to haze should be the actual original irrigated crop ET during the irrigation water right perfection period, minus the portion of precipitation that will be consumed by the vegetation established post-transfer. For the remainder of this presentation, I will discuss how we made these calculations of maximum transferable water for the proposed haze change of use from the R9 ranch. We computed the 30-year, 1980 through 2009, average alfalfa and grain corn ET that would occur under excellent agronomic and soil water conditions near Kinsley, Kansas, using quality-controlled daily climate data for Dodge City and Kinsley, and following American Society of Civil Engineering standard methods. These are the same standards recognized by the Supreme Court of the United States in Kansas versus Colorado. We then adjusted the resulting potential alfalfa and grain corn ET for R9 ranch actual ET conditions using metric ET mapping of Landsat satellite data from 1984 and 1985 perfection period. The metric methodology we used was developed by Dr. Richard Allen, who was one of the experts for Kansas in Kansas versus Colorado. I'll discuss the metric ET mapping in the next two slides. This slide shows the metric model ET map using Landsat 5 data for August 13th, 1984. The climate station for Dodge City is located here, and the station for Kinsley is located here, and the R9 ranch is here with its circles shown with a red outline. Landsat satellites orbit the Earth on polar orbits. Satellite scenes are arranged according to the path number, in this case path 34, and a horizontal row number, in this case row 29. Each scene covers about 1 degree of latitude and longitude and is captured at the same time of day for a given location every 14 days. Archived Landsat satellite imagery data is available from 1983 onward. Landsat satellite imagery data includes the reflected solar and thermal radiation data necessary to calculate actual ET by energy balance using the metric model. The difference between the incoming and outgoing energy plus the change in stored energy at the ground surface is the amount of energy consumed by evapotranspiration. This remote sensing ET calculation can be made for each 100-foot by 100-foot pixel. The result is displayed as the fraction of actual ET to reference ET for each pixel. This ratio is called ETRF. The ETRF is color-coded so that pixels with 0 ET or missing data are shown in white. Low ET values are shown in brown, on up to maximum potential crop ET values, ETRF of about 1.2, shown in dark green. From this, we can pick up the Arkansas River from the vegetation that's ETing along the river. We can also see that about half of the circles on the R9 ranch have low ET and appear to be not irrigated during the time of this imagery, August 13th, 1984. This slide shows the metric ET map zoomed in on the R9 ranch for May 25th, 1984. Note the lack of color uniformity on the circles and the low ET towards the outer part of the circles. This indicates the difficult irrigation conditions on the ranch and that most actively irrigated circles at the time had significant portions of the fields with ET below the potential. Remembering that consumptive use is synonymous with ET, we can see that the consumptive use on the R9 ranch is below the potential even for irrigated circles. Also note that many circles have very low ET on this late May date, indicating that they were not planted in alfalfa at that time. By analyzing 8 satellite images for 1984 and 7 for images for 1985 using the metric model, we were able to determine that on average, evapotranspiration on the R9 ranch was about 72% of the potential for well-watered alfalfa and grain corn. Putting this all together, we are able to estimate the consumptive use for the R9 ranch and the maximum volume of water that could be transferred by change of use without resulting in an increase in net consumptive use. On the left-hand side, we have the computations for alfalfa. The 30-year average potential crop ET is 46 inches. The mean fraction of actual to potential ET from the metric analysis of the 1984 and 1985 satellite imagery is again 0.72, or 72% of the potential. Multiplying 46 by 0.72 equals 3.1 inches of estimated average alfalfa ET on the R9 ranch. The 50% rainfall per KAR 5515 is 15.4 inches. The NIR computed by subtracting the 50% rainfall from the actual ET estimate is 17.7 inches. However, remember our earlier discussion that under non-irrigated grassland conditions, the consumptive use of precipitation will be greater than under irrigated conditions. By conducting a daily soil water balance and using 30 years of precipitation data from Kinsley, and estimated ET for native switchgrass, we arrive at an estimated post-transfer average consumptive precipitation value of 21.1 inches. Thus, the maximum net consumptive use post-transfer for formerly irrigated alfalfa fields is 3.1 inches minus 21.1 inches, which equals 12 inches or 1 foot. Similarly, for grain corn on the right-hand side of the slide, we find the maximum net consumptive use post-transfer to be 4.7 inches or 0.4 feet. Multiplying these net consumptive use results by the 2,901 acres of alfalfa and 2,247 acres of corn found by the chief engineer for the R9 ranch, we arrive at maximum transferable water by net consumptive use analysis from drying up irrigation on the ranch equal to 2,901 acre-feet for alfalfa circles plus 889 acre-feet for the corn circles for a total annual value of 3,790 acre-feet. This is 1,000 acre-feet per year less than the 4,800 acre-feet change of use volume modeled by the City of Hays. If the chief engineer were to permit the transfer of 4,800 acre-feet per year from the R9 ranch to the City of Hays, he would be allowing an increase in net consumptive use of more than 26%. The Kansas Water Appropriation Act does not allow for any increase in net consumptive use by a change of use from irrigation. Furthermore, we would argue that our finding of 3,790 acre-feet per year net consumptive use is a maximum value and assumes that 5,148 acres were irrigated during one calendar year on the R9 ranch during the perfection period. We believe the maximum irrigated acreage in a single year was likely less than 5,148 acres, but we have not done the analysis yet to determine that. We note, however, that the archived Landsat satellite imagery for such analysis is available. In summary, groundwater levels in and around the R9 ranch are trending downward despite the historical reduction in pumping on the ranch. Spatial analysis of groundwater levels and water budget show long-term local and middle arc subbasin groundwater storage declines, with local rates double that of the subbasin. These trends are not sustainable. Any allowed increase in water consumption will further stress the finite water resource in the vicinity of the R9 ranch. While recognizing the right of Hays to use its water according to the rules and regulations of Kansas, WaterPACK wants the chief engineer to make certain that the historical consumptive water use on the R9 ranch is scientifically accounted and any permitted water transfer from the ranch not be allowed to exceed the net consumptive use amount of the original irrigation right as per Kansas law. I'm sorry I could not be there today to give this presentation in person. I have presented a lot of material and I understand that it may have been difficult to endure. I do appreciate your attention and thank you.